Hello and welcome to the fifth talk of our online series, Behind the Scenes Analysing Anglo-Saxon Rendlesham. I'm Alice DeLeo, the Project Delivery Officer for Suffolk County Council Archaeological Service, and today we'll be hearing from Eleanor Blakelock about the metalworking evidence at Rendlesham. We're excited to be hosting this online series in partnership with two projects. Rendlesham Revealed, led by Suffolk County Council Archaeological Service, funded by the National Lottery Heritage Fund, and the Lordship and Landscape Project, led by Christopher Scull, funded by the Leverhulme Trust. You can find the videos of the earlier talks on our website at heritage.suffolk.gov.uk/Rendlesham. So I will now introduce you to Eleanor Blakelock. Eleanor specialises in Anglo-Saxon metallurgy and is known for her work as the lead metals scientist for the Staffordshire Hoard. As a metals specialist for the Lordship and Landscape Project, Eleanor has been investigating the metalworking evidence found at Rendlesham and what this can tell us about the materials and practices. So Ellie, when you're ready, over to you.
So what you're currently watching is a video of some experimental casting. And obviously what I'm going to be talking about is directly relevant to this. So we'll just wait for it to do this cast before I start my talk. Okay, so when we talk about metalworking and metalworking waste, I'm going to sort of give you a brief introduction to the types of metalworking waste we tend to find. So this is an experimental half, but you can see quite a lot of the common types of items. So we've got here the crucibles. These would have been used to melt the metal. And then we have over here a bunch of molds, which would have been used to actually create the objects that we are casting. In addition to those, you might find bits of metal waste, metal spills, bits of metal that have accidentally fallen into the fire, and you would often see quite a lot of charcoal deposits. But in addition to all of these sorts of more common objects, we sometimes find other types of evidence. So we sometimes find things like ingots and coin blanks. We rarely find sprues, which are the reservoir of metal before it actually goes into a mould. If we're very, very lucky, we might find some failed or incomplete objects. These are objects that have obviously meant to be in something, but they've just actually not worked. And again, if we're very, very lucky, we might find some slag or half lining to indicate that we've actually got a half on the site. Tools are an interesting one. We rarely ever find these on metalworking sites, and this is probably because they're handed down through the generations. And the place we tend to find tools of metalworking tend to be more in grave context than in metalworking sites themselves. And if you've got evidence for precious metalworking, you will sometimes also find litharge cakes and parting vessels, which indicate that you've got separation of and refining of the precious metals, so removing the gold and silver from the coppers or lead, or the parting vessels that are used to separate the gold from the silver. Now, Rendlesham is really unusual in that because of the way that the material has been collected, i.e. mostly metal detected, we actually don't have any of the typical ceramic waste or non-metal waste that we would expect to find. And this has created some interesting aspects to this project. But what is nice about Rendlesham and quite odd about Rendlesham is actually, in addition to the sort of normal metal spills and fragments that we would expect to find, there are actually a huge number of metal sprues, more than I've ever found or seen in any other site. We've also been quite lucky that we've got quite a lot of unfinished objects or objects that have failed when they were cast. We also have lots of precious metal offcuts and droplets that indicate we've got precious metal working, along with ingots of all the metal types and a few coin blanks. So Rendlesham is quite unusual in that it has all of those materials that we would expect or are less common on a metalworking site. So the aim of this project was to analyse the metal objects and metalworking waste, and we had several aims for the project. The first one was we wanted to sort of backwards reconstruct the casting technology from the incomplete and failed objects without the moulds. So we wanted to be able to try and work out what kind of casting methods they were using, but also try and reconstruct the moulds themselves. We wanted to investigate the metal economy as well. So we wanted to know where was the metal coming from and how much evidence for recycling we have in this period. So the next question was all about looking at the actual manufacturing method. So we wanted to identify the different techniques that were being carried out at Rendlesham, but we also wanted to build up a sequence of construction so that we can get an idea as to whether or not the Rendlesham objects have a different sequence of construction than other objects elsewhere. And we also wanted to try and look at the sort of decisions that the metal workers would actually have to make. And this is quite a nice thing about archaeometallurgy, is we can actually almost get into the heads of the people that are making these objects by looking at the decisions that they're making. And finally, we wanted to sort of look at the nature of the workshop and to sort of see whether or not we could say for certain if it was the same period as the palace site, the high status site, or whether or not it was, or how big the site was. You know, are they doing the copper alloy working and the precious working in the same building or same area? So we wanted to look at things like that as well. So to do this, we'd use various different methods. The first method is just by basically looking at the objects, both by eye, but also under a microscope. And this was to look at things like features and traits on the objects themselves to be able to pick out features. The next thing we did chemical analysis, and we used two different major techniques for this. So the first technique is scanning electron microscope, SEM-EDS. And this was for the copper alloys and the gold objects. And the objects go into the box behind my head here. And then what you can do is you can magnify down quite small areas and analyse pinpoint areas on the object. So it's actually quite a good technique. However, silver doesn't tend to work in this machine, certainly not to give us the results that we were after. So for silver, we were actually using a portable XRF, and this is the portable XRF here. With the gun, and the objects would have gone into this box here. So in addition to sort of the general composition analysis that we did, we also did a small study of lead isotopes and trace elements. And we chose some of the objects, the copper alloy objects, that we know were being made at the site, and some of the metalworking waste that we know was being made at the site, to try and see if we could A, work out where the metal had come from, and B, also to see if we could see any workshop groups. So first of all, I'm going to look at the copper alloys. Now, the first job was to sort of reconstruct the moulds and casting technology. And in this period, we have three different types of casting technology. The first one is open mould, where you basically just have an indented area in your mould and you pour your metal in. And this is used for very, very basic shapes. You can't get much detail using this method. The next method is a thing called piece mould. So this is where you're taking two or more pieces to create your mould. You seal it all up and then you can pour your metal in. The final method that we sometimes find in metallurgy is lost wax. And this is a very much more complicated method. What you do first of all is you create your object in wax. You add your various sprues and channels to the object before coating it in clay. At which point you then have to burn out that wax to create the void that you can then cast into. The thing with this mould type is that actually you don't tend to find the pieces of mould for it, because to actually get to your object, you have to break the mould into very, very small pieces, and they are often much more complicated moulds, whereas piece moulds can be used on a repeated basis. So we start looking at the features that we were looking at on the objects. The most common feature we found was flashing. And flashing is this material, the metal here between the two channels of the sprue, which is this bit here, the reservoir at the top. Now, flashing happens if your mould isn't quite flush. And what it does is it creates a gap, and the metal then falls into that gap before filling up the rest of the mould. And we saw this on a variety of different sprues. So you can see here, flashing here, but also we saw it on some of the failed cast objects and some of the complete objects. So it's a good indication that we've got a piece mould, because you don't get this in lost wax, you only get this in piece mould technology. The next bit of evidence was a few pins. These again failed objects that when they've cast them they've not worked. And if you plot the one side of the design with the other side, what you see is there's a complete misalignment between the two sides. And this happens if your mould doesn't quite fit, or it fits together, but it doesn't quite match the design. And again, it's a good indicator of piece mould technology. The other feature we tended to find on the sprues is we found this sort of spilled shape. And if you look at some experimental material, you can see quite clearly this is where the metal fills the reservoir and then spills over the edge of the mould. And the good thing with this is it actually can be used to tell us how thick the mould material was. And so we can actually get an average thickness for the mould material, which tells us a little bit about the properties of the clay or the mould material that they're using. We also found a number of double sprues. Now these are a good indicator that they're probably casting more than one object at a time. And we had some, obviously some, we had some sprues that looked a bit different. And these are probably failed cast sprues. So they're sprues that haven't quite worked. So if we see here, down here, we've got two sprues where they've actually probably worked, because you've got cut surfaces here where they've removed the object from the sprue, whereas these are very rounded. And if you look again at some experimental casting, you can see here where the metal has come all the way down but hasn't quite filled the entire mould down here. And what happens is if the metal gets to its cooling point, the surface tension of the metal will actually create a rounded edge, and that's what we're seeing here, and that's what we're seeing replicated in the archaeological material. So these are good indicators that these sprues were cast into a mould and it didn't work. Finally, what we have is we looked at the unfinished objects, and we use the features on these objects to be able to tell us a bit more about the type, how the mould may have been laid out. So you can see on this it's a buckle loop, but you can see at both ends here there's like a channel that would have gone off. And this is a good indicator they're actually casting these in chains. And here we have possibly an end of a chain, so we've got a channel that comes down here with no evidence for a channel going further down. And this does indicate that they're casting more than one object at a time, and probably in chains. And it's not just the buckles. We see this with the bag clasps here. This bag clasp has had the ends cut on both sides, which again indicates they're probably casting these in runs, in chains. Now, in addition to this sort of technology, the other type of technology we were potentially looking for is something like this. Now, this is actually an example from Hoxton, which is another very contemporary Anglo-Saxon site. And in this case, what you've got is you've got a single channel, probably from the sprue up here, that's been split into two side channels to cast two buckles at a time, buckle loops at a time. Now, we don't have anything quite like this at Rendlesham. We do have this small fragment that, if you turn it up the other way round, actually looks very similar. So it's possible from this bit of evidence that we've also got similar sort of casting method at Rendlesham as well. We just don't have the full version. So using all this information, we've been able to show quite clearly that they're using piece mould technology, and we're fairly confident they're casting more than one object at a time. Now, the interesting thing with the double sprues is that this can indicate one of two things. It could be indicating that they're casting more than one object in terms of a long and thin object, something like a pin, say. But it could also be used to indicate that they're actually casting in a much more complex manner. And this is an extreme version of the mould they potentially could be making at Rendlesham, which combines all the different factors and all the different bits of evidence. But as I said, it's the most extreme possibility. However, there are medieval moulds that look very much like this, so it's not a complete fantasy. So we're using this information to be able to sort of get an idea as to the possible types of moulds that are being used. So the next thing we did was we looked at the metal economy, and in this period what you tend to get is an awful lot of gunmetals. And gunmetals are a mixture of copper, tin and zinc. And this is the area where the gunmetals are. And at the top here we get brasses, and we get relatively few brasses. And then down here we've got the bronzes. And basically what this pattern shows us in this early period is that actually there are very, very few new brasses being introduced. And what we're seeing is an awful lot of recycling in the metal at this period, and lots of mixing of brass with bronze to create gunmetals. However, this is the pattern that's being seen in the late Roman period, and it's just a continuation. So it's nothing new to the Anglo-Saxons, but it's just a continuation of what's happening beforehand. However, by the 7th century, what we start to see is new brasses entering the metal supply, and it's really nice when we actually plot the early objects against the early data. It matches quite nicely, and when we plot the later objects against the later plots, again they match quite nicely. So the Rendlesham material isn't showing us anything particularly new, but it is fitting in quite nicely what we've already seen. Now the next thing we did was obviously this lead isotopes and trace element work. Now, because we've got a huge amount of lead in our objects from Rendlesham, unfortunately we can't source the actual copper. All we can do is source the lead. However, by doing this analysis, we have been able to show that there are no links at all to the sources in England and Wales. It's actually a much older geological source that's coming up in the isotope results. And these are sources that are, or the best match to these sources is continental sources such as Harz and the Massif regions. So what we're seeing continental material coming to the UK and being used. There is a small number of objects that show a slightly different signature, and these are all high zinc objects, and these are potentially coming from as far as the Aegean region. So even within the assemblage, we're seeing some differences, but the main thing to take home is actually none of this material is actually coming from the UK. None of it's coming from sources in England and Wales. And then finally, when we actually sort of look at the metalworking waste in particular, one of the things that we've been able to show is that the metalworking waste is mostly bronze or gunmetals, and there are actually no brasses within the assemblage, and these brasses would have fallen into this area of the graph. And this is quite nice because it ties in quite well with the fact that we think the High Sator site is earlier in the period. So the fact that we've got no brasses in the assemblage or in the metalworking waste would suggest that the metalworking site is associated with the palace. And then if we sort of look at a smaller subset of the metalworking waste, what we can do is we plot the pins and the unfinished pins against the sprues and metalworking waste that's being found. What we find is actually most of the pins that we're fairly sure come from Rendlesham plot really quite nicely with the double sprues, which would indicate that they are casting more than one pin at a time. And where we've got two clear objects that don't look like they've been made or are not similar to any of the other pins that have been made at Rendlesham, these are made out of brass. So again, this is probably an indication that these are probably coming from elsewhere. They're not coming from Rendlesham itself. Now, we can't talk about the metal economy without talking about wastage of metal. And as I mentioned at the beginning, one of the really unusual things about Rendlesham is the large number of sprues that we found. And if we take the amount of metal at these sprues, it's 242 grams of metal. Now that doesn't sound an awful lot, until we actually convert that into the number of objects that could have been used to make. So that would have made 161 complete buckles, so the whole thing. And so that is a huge amount of waste. And for me, who does a lot of experimental work, it doesn't really tie quite well with what you do. In a normal metalworking site, you would take any sprues that you cut off from your object and you would put them straight into a crucible beside the fire to be used in the next session. It's very unusual for you to throw a sprue away, given how much metal is often in them. So it's a very, very strange thing, and we have to try and sort of explain this. Now, there are possible explanations. The first one is the collection method, i.e., because we're doing metal detecting, are we picking these up far more often than we would on a normal excavation? Now, I'm not sure that this is the reason for it. There have been other areas that have been metal detected and they've not found as many sprues. And some of the excavations that I've been looking at, they've done sieving. So surely they would have picked them up in that. So I think there's something else going on here at Rendlesham. So could it be to do with the state of the site, i.e. it's a high status site, so they actually didn't need to worry about metal. They had enough metal in stock. So they just, got rid of them if they didn't quite work. And again, this possibly ties into the next possibility, is it to do with superstition? We talked about the fact that a lot of the sprues have these rounded ends to them, which indicates we've got a lot of failed casts. So did they just throw them away because they just thought, oh, it didn't work, throw it away? For me as a metalworking worker, I don't know why you would, but maybe there was a superstition attached to it. And then finally, there's always the, is it a ritual? Now, as a scientist, I don't tend to go into those sorts of things. I leave that for other people to talk about. So next thing we did was we looked at the sort of manufacturing methods for copper alloys. And this, we looked at these sort of finished objects and noting things like where we could see tool marks. So here you can see the filing marks from the polishing session. And here you can see actually the direction that the object has been drilled to create the hole. We also looked at sort of manufacturing marks and traits, and the buckles were quite an interesting thing because we had several different types of way of finishing off the tongue of the buckle. So here we have a single mark. Here we've got multiple marks, probably where they've made a mistake. But in some cases, we find no marks whatever from the pliers that we use to actually twist the wire in place. So it was a case of trying to look through these and seeing if we could see any patterns in terms of manufacturing. And then we also looked at things like the decoration techniques and made a record of that in terms of the site's objects. And the aim of this was to try and reconstruct a manufacturing sequence for these objects. So this is the manufacturing sequence for a buckle. So the first thing you'd have to do is you have to create your loop for your buckle. And obviously we've got the molds for that, so we can see that these are being cast in chains. You then take your object out, you need to remove the sprue and any flashing that's present. And then you have to sort of repeat the process to make the sheet here to make the plate and the wire to make the tongue. So you go through the same sort of process to get to that. At which point you can start to assemble your object to make up the various, the plate and the tongue before you do your final polishing and finishing off. I think at that point, at that stage, that is when you then apply your decoration. If it had been applied earlier, you'd see a lot more distortion in the actual stamping or line work. So I think the decoration at least happens in this end phase, and then it's probably touched up as well afterwards. So we can start to actually understand the process and the manufacturing methods that the ancient craftspeople are going through. So we now move on to precious metals. Now, the unfortunate thing with precious metals is we do have an assemblage of stuff, metalworking waste. We have ingots, both silver and gold ingots. We have sheets, gold sheets, and these are because a lot of gold working is done in sheet work. sheets tend to be more of a bit of evidence for us than cast waste in gold. We also have some coin blanks and the occasional droplets of gold metal and silver metal. We also had some interesting melted silver coinage, which is possibly an indicator that they're melting down coinage to turn into objects. But what we don't have at Rendlesham is sprues or unfinished or failed cast objects in precious metals. Now this is completely not, we'd completely expect not to find of those, because with precious metals you would not waste them, you would keep them. They are too precious to throw away. So I think that's quite to be expected, but we can't then reconstruct the mold technology or the sort of technology for making these in the same way. So the next thing we do is we look at the composition of the objects. Now, if we plot the Rendlesham gold objects against other gold objects from like the Staffordshire Hoard and Sutton Hoo and places like that, you'll see that they plot quite nicely in the same range as other objects. And the range goes from anything up to about 45% silver, but only up to about 5% copper. You rarely get above 5% copper. And this is the same pattern that's seen at Sutton Hoo and Staffordshire Hoard. The suggestion is that most of the gold objects in this period are being made from recycled objects and mostly recycled coinage that's potentially coming from the continent. However, one of the interesting things we found with Rendlesham was actually that when we looked at the coins compared to the object tends to be a purer gold content than the coins. And what this would indicate to me is that they are trying to reserve their better quality coins and better quality gold objects and melting them down to make objects, rather than just throwing anything into the melting point. So there's some sort of selection before they make an object. It's not just a case of randomly recycling whatever they've got. Now, one of the big questions I'm always asked about Rendlesham is the Rendlesham workshop where they made the Sutton Hoo objects? Now, it's very, very difficult to prove something like that. But what we did when we plot the metalworking waste against Sutton Hoo, there is a sort of general similarity in the distribution. There's one outlier over here, but the metalworking waste does fall quite nicely with Sutton Hoo. However, we can't use that to say for certain that they are definitely making objects here, but it's possible is the answer. And finally, for those people that know a bit about the Staffordshire Hoard and the work I did on the Staffordshire Hoard, one of the things we found was that we were actually surface treating the gold sheets by removing the silver to create contrast, and they're doing exactly the same thing here at Rendlesham with most of their objects. However, the thing that was really interesting was some of their coinage also had the same surface depletion, and that needs some more work because it was only a small collection, but it's an interesting possibility. If we look at silver, it's very much like the gold. It's got a very similar range to other objects analysed from the Staffordshire Hoard, and the only possible interesting thing that we could glimpse on it was that some of the weapon fittings, particularly those from the Staffordshire Hoard, seem to have a very different composition to the other objects from Rendlesham and other types of objects. But it's it's a very, very small data set, so it's quite hard to see. So it's a possibility, and it's certainly something for future research. So along with the copper alloys, we wanted to look at the sort of manufacturing techniques that we could see in the precious metals. So for gold, there are a variety of different decoration techniques, but the main one we see is filigree, which is this beaded wire that we see. And we saw quite a lot of that in Rendlesham. And again, cloisonné, and we saw a few objects in cloisonné as well. And this is the cell walls with the garnets inset. So there's a similar range of techniques that are being used at Rendlesham as there are elsewhere. In the silver, we had examples of gilding. We had stamps. Now it's interesting that these stamps were being used, or we could see similarities between stamps being used in the silver work and also potentially crossing over into the copper alloy. So there are very, very similar shaped stamps being used in both, which could indicate that workshops were working in both types of metal with the same tools. We also found a few yellow inlays, and that's the black material within this silver border. So we've got, again, a very similar, a good range of techniques being used at this site. Now, in addition to sort of creating a general sequence of production for the objects, one of the things I've been really interested in while looking at the Rendlesham material is actually the quality of the pieces, because there does seem to be some differences, and it's something we haven't really looked at before. So if we take the gold and garnet bead here, what we do is we look at the gold composition. Well, the gold itself is actually quite a good quality gold. And the cell walls to this bead are really quite regular. The garnets, on the other hand, are actually quite roughly cut, and they're certainly not as good as some of the objects that I've seen from the Staffordshire Hoard or Sutton Hoo. So they're very, very rough and ready. But they are using simple gold foils underneath the garnets to help the shine, and they are very well soldered. So overall, this is quite a good bead, good quality object. However, if we look at the sword pyramid from Rendlesham, which is one of their star objects, there's quite a lot of an oddity about this one. So the gold, on the other hand, is very, very similar in quality to that of the bead. And actually, what's really weird of it, it's got some of the largest pieces of garnet I've ever seen used in an object. But that's where the good quality ends. So the filigree work is actually really quite poor. It's very, very coarse as the overall design, but when you actually look at the beaded wire itself, it's very poor. So the main beaded wire is not too bad, it's not the best, but the two wires either side should be clearly beaded. And there is it's very, very hard to see that they have actually just been beaded. They're almost like a straight wire in places. So very, very poor beaded work. But the strangest thing about this piece is actually how they've constructed the object. So they've taken this design that they've soldered onto a panel, and they've cut it out. And they've cut it out quite roughly. So you've got bits of the gold sheet from behind revealed in places. You've got areas where they've cut into the gold wire. It's incredibly well roughly cut out. And then it's simply been soldered onto the edges of the sword pyramid. So it's not a case that they've done what you'd usually get, which is inset gold cell work with the garnet pieces inset into it. They've just put a slab of garnet on and stuck the filigree on top. It's very strange. The other thing we have is there's no gold foil underneath any of the garnets, and this basically results in a very dark, dull colour compared to the normal garnet work, and it's those gold foils that reflect the light back up and gives you the shine. There is also loads of evidence of poor soldering, so you can see floods and floods of solder all over this object, and a sign of a good bit of soldering is you can't see the solder. So the fact that we can see floods of solder indicates that they're potentially not doing their best piece of work. And what this shows is not everything that looks gorgeous and golden at the sort of first glance is actually that good. And we need to start thinking about the sort of quality and why we're getting these different qualities of pieces. Anyway, so in conclusion, we have clear evidence for metalworking at Rendlesham, particularly the copper alloys, but we do have enough pieces of precious metal waste and pieces like that to suggest that they are definitely, or to confirm that they are definitely doing precious metal working at the site, and it would therefore confirm that this is a high status site. We've been able to reconstruct the technology for buckles, pins and bag catches. Now we have these as evidence, but it doesn't mean that that's the only thing they're making. They're probably making a bigger range of objects. We're just not seeing all the objects that they're making. The composition of the metal does suggest quite a lot that they're actually doing a lot of recycling of all the different metals. But it is very strange that we're not getting those sprues being recycled. It's been very nice to have so many sprues, but it is very strange. And again, is this another indicator of status, i.e. they had enough metal that they didn't need to worry about those sprues? And finally, we'd be starting to see that not all objects are in an assemblage are equal, and we need to start looking at the quality of things. Even if I think back to the Staffordshire Hoard, we had objects that looked like apprentice pieces compared to some of the best pieces I've ever seen. So we need to start thinking about the sort of quality as well as how they're manufacturing. And again, this is just because we got some really rubbish objects at Rendlesham, or rubbish quality objects at Rendlesham, doesn't mean that Rendlesham isn't making the really highest quality stuff, because actually it could be that these objects were being brought to the site to be melted down to turn into new objects, because the gold was pretty good. It was just the quality of the actual object that wasn't. And finally, we've been able to sort of say something about the actual workshop itself, and it's probably likely that both types of metalworking, copper alloy and precious metalworking, was taking place in the same workshop. I can't see why you wouldn't, and it probably took place alongside other crafts such as leatherworking and stuff like that. And we have been able to show quite clearly with the copper alloys that it's likely that it's happening at the same time as the high status site.